All right, moving on to lesson 5, which is the families of polynomial functions lesson. So what we are going to look at this one is how can I find the equation of a graph, or how can I find the equation given the zeros, and what or what kind of differences would it make if I have a different a value in my function. So let's say if I give you a set of zeros, right? Would you be able to find multiple equations, or would it be one equation? And then how can you find the difference, and how can you do it? So if I'm looking at the first graph, so if you look at graph 1, set A, these are graphs for different functions. We have 3 different functions. What can you tell me about these functions? What do you notice? What's the same? What's different? So for now, you should have a list of different things to say, okay, they have the same, but they have different. Now, how about for set B? So let's look at what would be the same. So if I'm looking at this, I can say that they have the same. I can say that they have the same x-intercepts, right? All 3 graphs, they intersect at the same value, which is -2 and 1. All right. Can you tell me if they might have the same degree? Right? They have the same degree because they're both opening upwards. Not only that they're opening upwards, I don't care about that, but they have from quadrant 1 to quadrant 2, right? They're opening in the same direction, or quadrant 1 to quadrant 2. They have only they have 2 x-intercepts, and they have only 1 turning point. So I can say that they have the same degree. Now that would be true for set B as well, right? For set B, they have the same x-intercepts and they have the same degree. Now, what would be different? So if I look at this, I have different y-intercept, and they have maybe different compression, right? You see that they're skinnier or wider, and they have the difference, right? So let's write this down. So what they have the same, they would have the same x-intercepts or the same zeros. And equations have the same degree. And we can tell from the equations that they're degree 2, right? Because 1 and 1, 2, 1 and 1, 2, 1 and 1, 2. What's different, they have the same zeros, they have the same factors here, right? But what's different is if you're looking at the a value, right? That's what's different. So in here I can say they have the same y, they have different y-intercepts. They have different stretch or compression factor. And they have different vertices. So what you see here is you see that all of these equations, so if you're looking at equation I, triple I, double I, all of them, all of these equations, they have the same factors. The only thing I'm changing is the a value, or in this case, we're going to call it the k value. Okay, so we call these a family. These are a family of graphs. Okay, so they do look the same. They have the same shape, but they have different stretch compression. They have different y-intercept, different vertices. The only thing they have the same is they have the same x-intercept. So if we're going to describe the relationship between the graphs of functions of the form y equals k, x minus 1, x plus 2, where k is an element of the real, I can say the only thing I can say is they have the same x-intercept, right? And then we call these a family of graphs. So examine the following functions. How are they similar? How are they different? So if I'm looking at all of these, so I have y equal negative 2x minus 1, x plus 3, x minus 2, negative x minus 1, x plus 3, x minus 2, y equals x minus 1, x plus 3, x minus 2, and y equals 2x minus 1, x plus 3, x minus 2. So predict how the graphs of the function will be similar and how will they be different. So what I can say here, let me type that. I can say that they will have, as we've seen before, the same x-intercepts, but their shape and direction will be different due to the sign and value of the leading coefficient. So you can graph these using technology, using Desmos. I've already graphed it and I've already put it here for you. All right. So you see, look at the difference, right? The only thing that's the same, and if you look at this, the only thing the same is that they all intersect at the same x-axis, at the same x-intercepts, right? And then everything else is different. Their maximum value, or local max or local min, and their minimum value, right? Everything, their direction of opening, their y-intercept, they don't have the same y-intercept. So the only thing that's the same, and that we can see that is the same, is the x-intercept. Okay? So we call this a family. So a family of functions is a set of functions that have the same characteristics. Polynomial functions will, with the same zeros, are said to belong to the same family. So the graphs of polynomial functions that belong to the same family have the same x-intercepts, but have different y-intercepts. Unless 0 is one of the x-intercepts, then they will have the same y-intercept. An equation for the family of polynomial functions with 0, a1, a2 is written as k, y equals k, x minus a1, x minus a2, and so on and so forth, where k cannot equal to 0. All right. So here is the question. The zeros of a family of quadratic function are 2 and negative 3. Determine an equation for this family of functions. So since they're telling you it's a family of functions, you're going to have to write it as y equals k and then x minus 2, x plus 3. All right. Write an equation for two functions that belong to this family. Any two functions, it doesn't matter. K can be any value. So let's say y equals 8, x minus 2, x plus 3. You can pick any value for k. Y equals negative 3, x minus 2, x plus 3. You can even pick fractions if you want. Now, in this question, they're asking you to determine an equation for the member of the family that passes through the point 1, 4. So now they want a specific. They want one member of the family. It's like, you know, your family, if you have siblings, and then they want you to find a member of the family that has long hair, right? Or a member of the family that has a combination of long hair and blue eyes or whatever. Okay, so in this case, we want to make sure that the equation passes through the point 1, 4. So what we're going to have to do is we have to set up the equation. So y equals k, x minus 2, x plus 3. And then we have to use this point and then plug it in for x and y. So my y is 4, x is 1, and then we're solving for k. So in this case, it's 4 equals negative 4k. So k equals 2, negative 1. And then the equation, you have to write the equation, is negative x minus 2, x plus 3. And that would be your final equation. Okay, here's another example. The zeros of a family of cubic functions are negative 2, 1, and 3. Determine an equation for this family. So because it's a family, we're going to have to write it as y equals k, and then x plus 2, x minus 1, x minus 3. It's a cubic function. All right, now determine an equation for the member of the family whose graph has a y-intercept of negative 15. Now, because it's a y-intercept of negative 15, that means my point is going to be, 0 and negative 15. So that's the point. This is x, this is y. So rewriting the equation, I'm going to replace x with 0 and y with negative 15. So that's going to be 2, negative 1, negative 3, and that's going to be 6. So negative 15 equals 6k. Divide by 6, so the k value is negative 15 over 6. And then you can write your equation as y equals negative 15 over 6, x plus 2, x minus 1, x minus 3. Sketch a graph of the function. So to sketch a graph of this function, what do I know? I know the zeros. So I know that the zeros are negative 2, 1, and 3. So I'm going to start with this. I know that it's a negative leading coefficient, and it's a degree 3. So that means I'm going to start with this from this quadrant here, and I'm going to end up in this quadrant, quadrant 2 to quadrant 4. And I know the y-intercept is negative 15. So I know that I have to pass through this point. Okay. So the way this graph is going to go, I'm going to try my best. There we go. And that's going to have to turn and come back here. It's going to touch this. And then it's going to go up. And it's going to come back down here. All right. There's nothing happening here. I'm just going to try to fix that if I can. There we go. And make sure you put arrows because that's going to keep going up and down. All right. Okay. So similarly, if they give you an equation or a graph, you need to be able to find the equation. So in this case, the first thing you're going to do, you're going to find what your zeros are. And then you're going to use a clear point to be able to find your k value. So in this case, I'm going to use this clear point here, which is that's a -6 and that's a -1. Okay, so the point is -1, -6. So my zeros are -3. That looks like a -0.5. And so the x-intercepts are -3, -0.5, 1, and 2. So I have y equals k, x plus 3. Now, here's where a lot of you made a mistake on the previous assignment. When I have a factor or a zero of -0.5, it should be written as 2x plus 1 because it won't give you the same answer if you write it as x plus a half, okay? So it should be written as 2x plus 1, and then x minus 1, and then x minus 2. I'm looking for k, knowing that y is negative, x is -1 and y is -6. So that's going to be -6, k -1 plus 3, 2 times -1 plus 1, and then -1 minus 1, -1 minus 2. -6 equals to k. That's going to be 2. -2 plus 1, so that's going to be -1, -2, and then -3. If I multiply all of these together, they're going to be -12. So -6 equals to -12k, and then k is going to be equal to a half. So now I found what k is. I can plug it in there, and I have my equation that represents this graph. This lesson should not be new to you guys. You should have seen it before with quadratics. When we did quadratics in grade 12 and grade 11, I mean, we've had few of these questions in the previous unit, so this should not be a new lesson to you. If you have any questions, you know where to contact me. This unit is almost done, so there is one more lesson for this unit, and then we will have unit test after. Okay, so expect a unit test by maybe Wednesday next week.